So question 4 says solve the triangle. So right now we know one angle, so we need to find two angles. If we know two sides, we need to find a missing side. They ask us to find side C first. Now, you if we could use Pythagorean theorem, that'd be fine, but we don't have enough information to verify this is a right triangle, so we can't use right triangle trigonometry. Law of sines, the only angle we know is 89 degrees. So the only way this is going to work is if I knew uh, the opposite side, which I don't. So I can't use the law of sines because I need at least know one angle and its opposite side. Now, what I'm looking for is the opposite side. So remember, there's a formula that says if I want to find the opposite side, the law of cosines, to find the opposite side, if you will, is going to be the square root of the adjacent squared plus the adjacent squared minus 2 times the adjacent times the adjacent times the cosine of the opposite angle. So it's a big old formula there. So notice that we do know the opposite angle of 89 degrees. We just don't know the opposite side. So we don't know the opposite side, but this is the opposite angle. And the 3 and the 5 are the adjacents since they do make the angle. So we have all the information we need to use the law of cosines, which allows us to find the opposite side of an angle. So we're going to substitute in then the square root of, ooh, that's a little rough. Let me try that again. So the square root of, just so long. So the adjacents are the 3 and the 5. So we have a 3 squared plus a 5 squared minus 2 times the adjacents, which is 3 times 5, times the cosine of the opposite angle, or also called the included angle, which is the 89. So my mode is already in degrees, so we should be good to go. So the square symbol is above the x squared, so second x squared as a square symbol, and then I can just start typing 3 squared plus then 5 squared minus then 2 times 3 times 5, then the cosine of 89 degrees. So it's going to be 5.7 or 5.8. They say round to the nearest tenth. So 5.8. So the next thing they want us to do is find angle A. Well, to find angle A, notice now we do know the opposite side here. We said this opposite side was 5.8. So I could now switch over to the law of sines because we do know an angle and its opposite side. So if I want to find angle A, I do have its opposite side. So what I can do to find angle A is I could say the sine of A over A equals the sine of C over side C. So sine of A, we don't know angle A. That's what we're looking for. But side A was the 5. Probably should have brought this all down. And then the sine of C, what was angle C? I think that was 89 degrees, wasn't it? 89 degrees. So the sine of 89 degrees. And notice that side C is actually in our calculator. So this 5.785. So we actually want to make sure we don't round that till the very end on this. So we're going to not use the rounded version. We're going to use the long version of that. So to find the angle A, we have to kind of cross multiply and divide to start with. So 5 sine of 89. And then we're going to divide by, and I'll go up here and copy this in, this 5.785 thing, so it's not rounded. And that's going to give us then this 0.864. So what I have now is the sine of angle A is going to equal this 0.864. Now remember, to find angle A, we have to use the inverse sine of that. So the inverse sine of this is going to give me angle A. So I'll go inverse sine, go up here and copy this in, close it. That allows me not to round. And that'll give me then the angle of 59.7. And they say round to the nearest degree, so that's going to be 60 degrees. Now, to find angle B, we can just go ahead and go 180. We know that angle C was 89, and angle A, that's the 60, if you will, is going to give us then angle B is 31. So I actually don't have to use any trig at all, just 180 minus the 89 minus the 31 is going to give me the missing angle. Since we know two angles, we can subtract from 180 to find the third angle. So 31 degrees, if I round to the nearest degree, would be angle B.